Let's do this curve sketching for this equation right here. So let's see how we can do this. First of all, to do this one, we have to find the domain, intercept, symmetry, asymptote, intervals of increase and decrease, and find also local maximum, local minimum, and also intervals of continuity and no, not concavity and inflection points. Also, then we can finally sketch the graph. So let's begin with the domain. So in this case, if you see the equation, x can be any real number, but in the bottom, if you see, it's x minus 1, but denominator cannot be 0, because if it's 0, this will become undefined. So that's the only impossible value that we can have. So to denominator to be 0, what you have to do is, if this is going to be 1, like if I plug 1 for x value, it will become 0. So that's the only value that's not going to exist in the domain. Other than that, we are going to have all real numbers. So therefore the domain is going to be equal to all real number except 1. So x is not going to be equal to 1, and we are going to have all the other real numbers. And then we have to find the intercepts. So to find the y-intercept, I have to set x is equal to 0 and find the y value. So in this case, if I set x is equal to 0, it will become y will become 0. Therefore, my y-intercept is 0. So it's going to be, the point is going to be 0, 0. Then I had to find the x-intercept. To find the x-intercept, I had to set y is equal to 0. So if I set this y is equal to 0, denominator multiply this side and it will become 0. Therefore, we have only x in the numerator. Therefore, x is going to be equal to 0. And if you find the value x is equal to 0, it's going to be same thing, 0, 0. Then we have to find the symmetry, whether it is symmetrical or not. To find symmetry, what we have to do is we have to set f of minus x and find the values. So in this case, if I set f of minus x, this will become minus x over minus x minus 1 square. If you square any negative number, that's going to become positive. Therefore, this is going to be minus x over x plus 1 square. So in this case, to be odd symmetry, so to be even symmetry, this should be equal to f of minus x should be equal to f of x. But in this case, that's not true, because you see the original equation and this equation is not the same. Therefore, this is not even, this is not an even symmetric. And to check whether it's odd symmetry, we have to see f of minus x is equal to minus f of x. So if you see this value, this is f of minus x, this is not equal to minus f of x, because minus f, if you put minus f of x, what you have to get is you have to get minus x, then this whole value should be a negative number. But in this case, this is not true for this case. Therefore, this is not an odd symmetry. Therefore, this is not a symmetrical function. So that's how we find the symmetry. Then the next one is asking for the asymptote. So to find the vertical asymptote, I have to set the denominator equal to 0 and find the x value. So in this case, if I set the denominator x minus 1, 1 square is equal to 0. So what will I get is, so let's see, I have to expand this one. So it's going to be x square minus 2x plus 1 square, right? So this is the value. Then if I expand this one, I can factor this one. So let's see what we get. So basically this comes out to be, so when I multiply, I have to get plus 1. When I subtract, I have to get negative 1. When I add, I have to get negative 2. So the value that will work is minus 1 will work. So let's see, minus 1 minus 1. So minus 1, therefore x is going to be equal to 1. So x is going to be equal to 1. That's going to be that's going to be vertical asymptote. Then I have to find the horizontal asymptote. To find the horizontal asymptote, what I have to do is I have to set the find when limit x approaches infinity, what is the y value. So that's going to give us the horizontal asymptote. Let's see what we get if we plug that infinity. So in this case, to do that one, I have to expand the bottom part. So if I expand the bottom part, it's already expanded right here, so I can directly put it in the equation. So let's see, f of x is equal to x over x square minus 2x plus 1, 2x plus 1, and if I divide, I have to divide everything by highest power. So in this case, if I divide everything by highest power, this is going to become 1 over x divided by x square over x, x square, x. So this still limit x approaches infinity, then minus 2x over x square plus 1. So in this case, if you see, if I apply infinity, this will become 0, and this is going to be whatever the number divide 0, that's going to be 0. So therefore my horizontal asymptote comes out to be y is equal to 0. So this is our horizontal asymptote. Then E part is asking for the intervals of increase and decrease. To find that one, I have to take the first derivative of this one. So if I want to take the first derivative, I have to use the quotient rule. So, and if you do the quotient rule, you will get the value of minus x minus 1 over x minus 1 cube. So this is going to be the first derivative, and from this one you can find the increase and decrease. So to find the increase and decrease, I have to find the critical numbers first. In this case, to find the critical numbers, I have to find what the value that makes this one undefined. So in this case, if x is equal to 1, this will become 0. So that will make this one undefined. So x is equal to 1 is a critical number. And the other one is going to be, if I set this derivative equal to 0 for the whole equation, what the value I will get. So if I set this one 0, this denominator multiply this one, and that become the 0, and only the numerator is left, and that's going to be minus x minus 1 is equal to 0. Therefore minus x is going to be equal to 1. Therefore x is going to be equal to minus 1. So these are the 2 points that's going to give the critical numbers. And now we have to check the values, the values between the critical numbers. So in this case, minus 1, 1. So let's take minus 2 and put it in this equation. So if I put minus 2 in the top, we will get a negative number, because minus 2, so it's actually minus 2 minus 2 plus 2 plus 2 minus, so it's a positive number. And in the bottom, minus 2 minus, so it's cube, it's negative. So positive divided by negative, it's going to be a negative value. So this is decreasing. And then I have to find a value between minus 1 and 1. Let's put 0. So if I put 0 for this one, this will become minus 1, so it's a negative number. In the bottom, if I put in the 0, it's going to be negative number, because negative 1 is left, and power cube is going to be negative. So negative divided by negative is going to be positive. Therefore this is going to be increasing. Then I have to find a value greater than 1. Let's pick 2. So if I pick 2, it's going to be minus 2 minus 1 is going to be negative value. And here in the bottom, 2 minus 1 is a positive value. Positive power cube is going to be positive, and negative divided by positive is going to be a negative value. Therefore it's going to be decreasing. Then I have to find increasing and local maximum and local minimum value. So in this case, first of all, before we find the local minimum, local maximum, we have to look at the asymptotes. So if you look at this, we have vertical asymptote at x is equal to 1. Therefore there's nothing nothing is going to be in this point. And if you look at the minus 1, it's decreasing and increasing. Therefore we are going to have local minimum at this point, because it's going to be something, the graph is going to be something like this, right? So this is going to be local minimum. Then we move to the next one. Next one is asking for find the intervals of concavity and the inflection points. To find the concavity, what I have to do is I have to take the, so I'm doing the G part now. So G part, this is F part. So G part, so find the intervals and concavity. To find that one, I have to take the second derivative of this one. So we have first derivative right here is minus x minus 1 over x minus 1 cube. And if I find the second derivative of this one, I will get 2x plus 4 over x minus 1 power 4. So this is my second derivative. Now I have to check the critical numbers in this case. So if I check, there are two ways to find critical numbers. First, we have to set the value that make this equation into undefined. So in this case, so if I put 1 for the x value, that will make the denominator 0. Then it will make the equation undefined. Therefore, s is equal to 1 is a critical number, and I have to make the whole equation equal to 0 to find the other critical number. So in this case, if I make the second derivative equal to 0, the denominator multiply this 0 and that will become 0. Therefore 2x plus 4 is equal to 0. So let's see what that will give for us. So if 2x plus 4 is equal to 0, then 2x is equal to negative 4. Therefore x is equal to negative 2. So this is another critical number. Now we have to check the values in between the critical numbers, whether it is positive or negative. So in this case, I take the negative 2 and 1. So let's see for the negative 3. So if I plug negative 3 in this equation, 2 times negative 3 is negative 6, plus 4 is going to be negative 2, so it's a negative value in the top. And if you see at the bottom, it's power 4. So if you have an even power on the bottom, it means it's going to give the positive number anyway. If the value is negative or positive, doesn't matter, because if you power any negative or positive number by an even number, that's going to give you the positive value. So in this case, if this is negative divided by positive, this is going to be a negative value. And the second, I have to choose value between negative 2 and 1. So let's pick negative 1. So if I put the negative 1 right here, it's going to be a 2 times minus 1 is going to be minus 2, plus 4 is going to be 2. So it's a positive number divided by positive number. It's going to be a positive value right here. Then I have to pick a value greater than 1. And if I pick, let's say 2, so 2 times 2 is going to be a positive value. Positive divided by positive, still going to be positive. So these are the points right here. Now I have to check the inflection point. In this case, before I go for the inflection point, I have to check the asymptotes. In this case, we have an asymptote as x is equal to 1. So therefore, this is not going to touch x is equal to 1. Therefore, there's nothing going to happen in this point. But x is equal to minus 2, that's not an asymptote. So we are going to have an inflection point at that point. So x is equal to minus 2 is an inflection point. So let's say inflection point. And when x is equal to minus 2, if you plug that value in this function, so minus 2 over minus 2 minus 1 square, it's going to be minus 2 minus 1 is going to be minus 3, square is going to be 9, then minus 2 over 9. So that's going to be the y value in this minus 2. So now we are ready to draw the graph. So from this information, let's see what we get. So we know there's a vertical asymptote where when x is equal to 1. So let's draw this one. So it's going to be something like this. And also we know there's a intercept right here when x is equal to 0 and y is equal to 0. So that's the only point that's going to cross this axis, x-axis and y-axis. So in this case, let's see other values. So first of all, I have to know increasing and decreasing. So in this case, if you see negative 1 until negative 1, this function is decreasing. So decreasing, also we know this there's a vertical asymptote, it is in y is equal to 0. So it means along this line it's not going to touch until 0. So let's see what happens. So let's all check all the values. So first of all, we have intercept 0 0, then see this is not symmetry, vertical asymptote at 1, then also critical numbers and local minimum at negative 1. So let's put that value right here. So negative 1, we are going to have a local minimum, and if it's negative 1, if I plug this value in this function, negative 1 over negative 1 is going to be negative 2, square is going to be 4, negative 1 over 4, so it's going to be somewhere right here, and that's going to be the minimum point. Therefore we know the graph is going to be coming like this. Also this is we have to note the inflection point. This is at 2, so at minus 2, so before minus 2 it's minus, so it means concave down before minus 2, and after minus 2 it's plus, it's mean concave up right here. Then after 1 it's plus, therefore it's concave up again. So let's draw concave up until 2, and when minus 2 it's minus 2 over 9, so it's going to be somewhere here, and then it's from -1 to between -1, before -1 and after -1 is changing into negative into positive, so it's a parabola opening up. So it's going to be something like this. Then it's passing through the origin, and it doesn't meet the asymptote, it's just approaches the asymptote. So the graph is going to be like this. And also after this, we know after this is 1, right? 1 is my vertical asymptote. So after 1, say let's see what happens after 1. So in the first derivative we found it's decreasing. In the second derivative we found it's concave up, so concave opening up. So it means decreasing and concave opening up. So this is the kind of graph that's going to be satisfy both conditions. So this is how the graphs look like, and that's how it's done. I hope you guys like this video. See you next time.